Hello, this is Mr. McMurray, and we are doing the Measuring Vectors Graphically worksheet, or the Graphic Vectors worksheet, as I like to call it. All right, and you will notice that there are pieces of graph paper. These you can download, and then hopefully you can download, we'll see. And then you can actually draw it on there, okay? And then there's a worksheet with problems on it where you can show your answers. All right. So we're going to look at the first one. Problem number 1 says, after walking 11 kilometers north from camp, a hiker then walks 11.0 kilometers east. What is the total distance? Okay, well, the total distance is pretty easy. We just add those two together, 11.0 plus 11.0, and we get 22.0 kilometers, because they both had one decimal place. We're adding them, so we do the least number of decimal places. So he walked a distance of 22.0 kilometers, and we don't need to put a direction because it's asking for distance. And distance is a scalar quantity. It just has an amount. It does not have a direction. All right, now, on the other hand, it also asks us what's the total displacement from the starting point. All right, so let me try something here. Okay, so we know that this guy went, start at 0 here. Okay, this 0 went 1.5. I should use the other side so I could measure that. Or excuse me, 11.1. So it's barely over 1 there. Okay, east. We also know that he went. I can put it that way. Sorry. Let me try this again. We also know that he went. I'll put this one over here. 1.1 north. Okay. All right. So that's what we know so far. All right. Now, in order to figure this out, we need to figure out where he ended up. Okay. Now, there are two ways we could do this. We could say, well, oops, what I meant to do. Sorry. Let me try that again. Okay. All right. Okay. Now we can move this over here. We could say that, well, he went north first, and then he went east. Okay? Or we could say that he went east first, and then he went, hang on, click on the thing here, okay, and then he went north like this. Now the interesting thing, whether we went north and then over here, or we go this direction, we still end up with the same spot over here. So he started here either way, and went north and east, or he went east and then north, and the distance from where he started to where he ended up is the same distance. That is his displacement. So either way will give us the proper displacement. Okay? If you take two vectors and put them head to tail, so here's like the end of this one, so it's an arrow, and then this one, which is an arrow up here, okay, then it will show us where he ended up at. All right? Either way is correct. But when we measure where he is from where he started, all right, we're going to have to put our protractor at our beginning spot. So our little hole or crosshairs right there is going to go where we began. Right there. And we're going to line up on this east-west line. And so I'm going to have you draw the east-west direction first, then do the north or south. Because that way when you set your protractor on, you'll have a line to put it on here. If we went this direction and this direction, all right, you might be tempted to measure this angle over here. And that's not the angle we want to measure. We want to measure how far north he is of east, because we know he went northeast, so it's going to be north of east. So we're going to put the east direction first, and then that way this angle right here is what we need to measure. Okay? All right. So the first thing you need to do is draw the two lines like we did here. Okay? And then we're going to move this out of the way. All right. We're going to move the ruler over. And the first thing we need to do is draw our resultant. Remember, the resultant is from where we started to where we ended up. Let's see if that's it. Nope. Wrong way. Let's try again over here. Okay. So we are going to measure that distance and draw the line. So let me draw the line first. Okay, I made the line a little smaller. Hopefully that will help. And I'm going to make this line a dotted line. Okay. And hopefully that way it looks out like that. Okay. Now, first thing I need to do is measure how long this line is. That will give me the magnitude of my resultant, or my displacement. Okay. So in this case, if I measure this, and if I had the measure over here, I would get about 1.4 to 1.5 or 1.6. Okay. Alright. Alright, there we go. That makes me feel better. I can see my little marks now. So we can see that this is about 1.5. Now remember, if we go to the tenths, which this does, we need to estimate it. Mine is about halfway between 1.5 and 1.6. So I'm going to say that's 1.55. Okay. So for my displacement, it's going to be 1.55. Now, let me pause for a second here. Okay, if you remember, our original measurement was 11. Now, we could have drawn a picture that was 11 by 11, or we could have changed it to 1.1, which I did. I moved the decimal over here and made 1.1, so I have a little triangle. If you want to do 11 by 11, you can do that, and it would still be the same thing. But since I did this one, I get 1.55. I need to move my decimal back over. When I change this to 1.1, now I need to change it back to 5.5. Okay, I mean to move the decimal. So instead of 1.55, I'm going to have 15.5. So my correct answer is going to be here is going to be 1.55 kilometers. So I have 1.5. Excuse me. After I said that. Okay, 15.5 kilometers. Okay, that's my distance. Now the other thing I need to know is what is the displacement. So to do that, I'm going to have to bring my protractor over here. I always put the 0, 0 spot where I began at the beginning. And this time I have a very short line, so it's hard to see where the line's going to cross my actual protractor measure out here. So I'm going to put my ruler there so it shows me where it would go to. And according to mine, here's 50, so that'd be 48, 49, 48, 47. So it's about 47. So we're going to put that on 47.0, because it's exactly on 0.7 degrees. Alright, on mine that is the option button plus K. I don't know if that works on other computers, but that's what it is on mine. Alright, 47.5 degrees, and it is north of east. So I'm going to put north of east, and that would be my answer for that one. Okay. Now, if you'd done it 11 by 11, you have a bunch of big triangle, but it should measure about 15.5. So you put 15.5 kilometers, and the angle should be here. All right. Now, since these two sides are equal, technically this should have been 45. It's okay if you're a little bit off, because I'm going to give you a little bit of leeway if you're a little high, a little low. But you need to measure it as accurately as you can, so your answer is as close to the correct answer as possible. All right. Now, let's clear this one out. And let's go for the second question. Alright, second question is about a plane, and this plane is flying due north at 1.00 times 10 squared, or 100 meters per second. Okay, and that'd be about 200 miles per hour. And he is in a strong wind that's blowing 5.00 times 10 squared. That's 500 meters per second. That's 1,000 miles an hour. You should not be out in a wind like this, obviously. Okay, so let's just say that it's a ridiculous amount, but that's what it is. Okay. Now, if we're going to draw this, we can't go 100 by 500. So why don't we go 1 by 5? We'll just have to remember our answer needs to be multiplied by 10 squared so that we get back to our right units. Okay. Now, first of all, it's going north and it's going west. Well, we're going to do the west one first. We said I'll always do the east-west line first. Okay, that will work out better. So I'm going to turn my ruler so I can do an east-west line. And I need to put, right down here, go put the number of the problem over here. So I'm going, this is number 2. I'm just going to put a circle around that. This is number 1 up here. Okay, I'm going to start right there, so I'm going to hit my number 2. And I'm going to go, how far over? 5, centimeters. All right. Actually, I should have gone this direction. Start from here, going over here. That's 5 centimeters west. Okay. Now, you always start at the end of the line. Since I went west, this is the end of the line right here. And from that end, I am going to go. I am going to go 1 centimeter north. Move that over here so it'll line up with that. Okay. Here's my pencil, and I'm going to go 1 centimeter north. Stop right there at 1. Okay. So those are my 2 directions. Then I need to draw and measure my resultant. Put that one right there and that one right there. Mine will not let me put it exactly. There's, let me click in between there. But okay, and I'm going to draw my resultant line, which is going to be the dotted line, so that way we can tell which one it is. It's usually going to be the hypotenuse. If you don't want to use them big fancy geometry words, but that's what they're for, so let's use them. Okay. All right. The hypotenuse is going to be your resultant, or the result of the 2 things. Now, notice this time our lengths are not distances, they are meters per second, or speed. That's okay. We can do this with any kind of vector, and we can draw it and come up with the right answer. Okay, so wait, how do you draw meters per second? You just draw on the right length and it will work out. That's the magic of geometry. All right, so here we go. We need to find out how long this line is. All right, so I'm going to do that. Alright, I'm going to bring it up here to 1 or 0. Oops. It won't let me go that far. Okay, so we're going to have to do it this way. Okay, so we're going to do it there. Alright, so from 2 to 7 centimeters, that would be about 5. And it's probably going to be a little bit over. So I'm going to say mine is going to be 5.10. Okay. This measures to 10, so once again I need to put the hundreds place. But remember, we need to put times 10 squared. I don't know if it'll let me do an exponent. Let me try it. Yes, it will. Okay, so exponent squared. Okay. And it would be meters per second. Alright, now I need to know the direction. So to do that, I'm going to have to, the general direction, first of all, we went west and then north, so this is going to be northwest or north of west. Alright, but I need to know how many degrees north of west. So I put my 0 starting point in the hole on 0, and I look at my line. My line goes up this direction. So, one of these days, Mr. McMurray will remember not to move this until it's ready, but, okay. If I extend my line, use my ruler, oops, why would we need to be, is it? Alright, let me move it there so that I can see where this crosses. You will see, it's kind of hard to see because the 2 there, but it comes out across about 11, maybe 11.1, something like that. So we're going to put 11.1 degrees, and we know that this is, once again, north of west. Okay, and that's how you would do your answers. All right. Now, this is how most of them will work. You'll do these 2 directions. Always draw the east-west line first, then draw your resultant, measure it, and then measure the angle that it is from the east-west line. Okay. There's a question number 7 that I'm going to do another video to show you how to do because it's a little more complicated. Okay. All right. Well, hopefully you'll do well in this, and let me know if you have problems, and I'll see what I can do to help.